Hello. Yes.
Yes, sir.
Hello. Is the slide is changing is visible?
Yes, sir.
Okay. Okay.
Sir, this is
Okay. I'm
MPH
waiting. Just
005.
yes. MPH-5 electronics. Okay.
Yes.
So you all people from Odisha or somewhere? Hello.
Yes, sir.
You belongs to Odisha or the which state?
Odisha.
Okay.
Sir,
Odisha, sir.
we are
Okay. Okay. Okay.
from
Good.
Odisha.
Good. Good. So all are Oriya? Not. I think not Oriya because many of the also. So you are all taking the part actually IGNO classes and actually just you are doing the job and after that you are taking the part this distance courses or hello.
Yes, sir.
So you are taking all the part this distance courses from IGNO, na?
Oh, yes, sir.
Okay. So this is second semester.
फर्स्ट सेकंड दोनों सेमेस्टर है सर.
Okay. Okay.
फर्स्ट ईयर.
Sir, both second semester.
Okay. 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 So you got the part materials, na?
यस सर.
Yes, sir.
Okay. So you all are part doing the job and you are doing the part this distance course.
हाँ, यस सर.
Okay. 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 Good. So please inform so that I can start actually. Or shall I start?
यस सर.
Shall I start?
Good evening, sir. Yes, sir.
Okay. Okay. So good evening to all. Uh, so this is the part actually syllabus for MPH-05. So you have the part electronics. And it's particularly part in this course we have to start actually this the entire so I'll be just actually start the part this the introductory classes like the part if you gone through the part syllabus. Okay, so I may I think that you may all are part acting the part syllabus and I will be cover actually most of the part of the part syllabus in this counseling. Okay, so let me start with this so we'll first go to the actually the power diet. So basically, you know, when we start the part electronics, we must start with the part the basic fundamentals with the part the devices, and particularly the first devices will come just like a part a power diet. Okay, so in this introduction classes that I'll start with the part the different power devices. Okay, particularly power that's a diode, LEDs, and also the part construction, the details, working principles, okay, and also the LEDs. So the part whatever the part diets are there, I'll just have a put the parts just the brief ideas, and if you have any doubt that you can also ask me. Okay,
ओके सर.
I think have you gone through the part the data syllabus all of you? Hello.
Yes, sir.
Okay, so I think in the part syllabus you can find yes let me see here. Yes. So in the past, particularly electronic devices. So particularly you have to find you have to read actually construction working, biasing, IV characteristic, frequency response, and application of the diodes, and which will include actually power diode, LED, laser diode, solar cell, photodiodes, and the varicave diodes, PIN diode, tunnel diode, con diode, and the transistors. Okay. So I think that today I maybe cover most of the parts of this first electronic devices. Okay. So let me come to the part this power diode. So all of you know the diode is a for simple semiconductor device, and which includes the two layer basically. Okay, two layers and two terminals and a single junction. This is the part basic fundamentals of a part that when you can think about a part diode actually. The junction of the part normal diodes can be formed through semiconductor like P-type and N-type, because when you can realize a part actually semiconductor or a junction diode, we must have a P-type and also part N-type. The terminal of a P-type, it is known as part anode fundamental, and whereas a terminal at the N-type, that is known as part cathode actually. So there are for different kinds of the per diodes that is available in the market, and each type has its part own, but its one feature and also the part own applications depending upon the part requirement. So in that context, let me start with the part the power diode. Is the slide is visible to all of you?
Yes, visible.
Okay.
Yes, sir.
Yes.
So okay. So you know the part the power diode actually just this is for simple part general diode. It has a two terminal like anode and cathode, and the two layers like a P and part N that is used in the power electronic circuit, and that is why it is known as per power diode actually. Okay. So it has basically the two layers. One is called the part of P and the part other is called N, and the two terminal like a part actually anode and the part cathode. And this diode is part more complex in construction as well as in operation, because so simply making a part PN junction diode, not putting a P-type semiconductor over the N-type semiconductor. Rather that you have to follow there are part some mechanism, and also there is a part some of the some processes to build up a part PN junction. Okay, so that is why this is a part complex, because the part low power devices has to change to make them appropriate in high power applications. So the simple power diode can be act as for the part high power applications if we can change the part constructional details actually. Okay, then this is a part diode that you may have seen in your part in day-to-day life. Okay, and in power electronic circuit actually, this diode plays an essential role actually, and it can be used as a part rectifier in converter circuit, voltage regulation circuit, and the reverse voltage protection, etc. So these are the part diodes which are particularly used in part many of the electronic circuit in many of the part electronic circuit to just the voltage regulations, or also converter circuit, and the part reverse voltage protections. These diodes are related to the signal diode, except for a slight disparity in its construction, because sometimes these diodes also related for signal diode, because these diodes particularly used in also part as a signal for transmitting and also the part receiving, just like a remote also used in part in receiving the just LEDs that particularly used for the sensing the signal, means sending the signal to the part devices and also receiving the part signal from the other devices. So the doping level is a signal diode for both P layer and N layer is the same, and but power diode, the junction can be formed among a heavily doped P plus layer and a lightly doped N minus layer. So P plus means that means we are doping of the in the P side with the heavy that is a part what we call the P type impurity. Okay, and also the part that is also part the impurity, or that is a part N type impurity also added to the part N layer. So this can be this is a lightly doped, okay, that is N minus, and heavily doped, that is a part P plus. So these are the part the two semiconductor which are actually before making construction we can make the part a heavily doped P plus layer and a lightly doped N minus layer. Then if we can see the part construction actually, this is called the part the power diode. So you are able to see here. So this is a part n minus means this is a part a P plus, and this is a part N plus, where you can find this is a part actually hole type. Okay, and the construction of this diode is includes three layers like a P plus layer, N layer, and N plus layer. You can see P plus, N, and also the part N plus layer, N minus layer, N plus layer. Here, the top layer is the part P plus layer, and it is heavily top, and the middle layer is the part N minus layer, and it is lightly top. Okay, and last layer is part simple N plus layer, and it is also part heavily top with the part electron. Okay, But you can see this is n plus layer and this is p plus and this is n minus. But this n minus layer, what we call actual part, this is light dot. Okay, that is why we are putting part n minus. But when it's p plus are given and n plus are given, that indicates a part it is heavily doped. And there are two terminals, that is anode and the part cathode, and this is the part symbol of a part power diode. You can see this is the part the p type and this is the part n type. This is plus and this is minus, and the two terminals are there, and the part current flowing to the part diodes here. So here p plus layer simple act as anode, and the thickness of this part layer is basically you can find 10 micrometer, and the level of the doping is for 10 to the power 19 per centimeter cube. So you can see the doping is for very high. Okay. Hello.
Yes, sir.
Yes, sir.
Is the slide is changing there? Hello.
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
next, we can come to the part this n plus layer. So you have seen actually part this p plus layer actually have the length thickness of 10 micrometer and the level of the doping per 10 to 19 per centimeter cube, and the n plus layer act as a part cathode, and the thickness of the layer is part 250 to 300 micrometer, and the doping level is part also the same 10 to the power 19 per centimeter cube. And the n minus layer actually act as a middle layer, or that is called drift layer, so which can help the part electron concentration and hole concentration to move in both the part directions, direction depending upon the part voltage applied at the two terminal. Okay, so this act as a part middle layer or drift layer, and the thickness of this layer mainly depend on the part breakdown voltage, and the level of the doping is part found to be 10 to the power 14 per centimeter cube. Once this layer with increase width increases, then the breakdown voltage also part will be increases here. So this is the part you can see, this is the part construction details of the part this power diode here. Then question is here, how if it is a heavily doped p plus and also the n plus and the n minus layer with a different concentration, then how it will work actually, because the n minus layer that is which is present in between the p plus and n plus will place a part. You can see there is a part a drifting layer, or that is a part or that is called a part middle layer or drift layer, which helps the drifting the electron from one region to the part other region. You can see the working principle of this diode is similar to that of the normal PN junction diode. So when you can apply the voltage at the two terminal, when the voltage at the terminal at the anode terminal is high, then you can find the voltage of the cathode terminal and also the part diode. The diode you can found to be part conduct actually, and the range of forwarding voltage drop in this diode is very small, and approximately from 0.5 volt you can find that is up to 1.2 volt. And in this mode the diode works as a forward characteristics. Okay, so why the forward characteristics? Because we apply the part positive voltage at the anode and a negative voltage at the part cathode, so that there is a forward biasing setup, or the forward bias is developed, and this helps the part electron to move from the part from the n region. That can be the current can flow from the part p type to the part n type, and whereas the electron flow takes place inside the part material or inside the part junction from n type to p type here. Okay, then if the voltage of the cathode is higher than that of the voltage of the anode, then the diode performs as a part blocking mode. You can see when the voltage of the cathode is higher than that of the part voltage of the part anode, then the diode performs as a part blocking mode, and in this mode the diode performs like the part reverse characteristics, just like when P will be supplied to a part negative voltage. Okay, and the P type P plus type will connect a part negative terminal, and N type connect with the positive terminal, then you can find the diode simple act as a part reverse biased. Okay, just you can see the operation. This is a part circuit, this is a block diagram. So this is a p plus, this is n plus, where you can find p plus the part there is a part large number of the holes, and n plus there is a part there is large number of part electron, and this n minus is a part simple slightly doped. But when there is a forward bias applying, I told the part this p type current of part positive and n type is current of part negative, so that electron flow takes place from that of the part from n to p, and there is a current flow takes place from the part p type to part n type here. So then coming to the part biasing, actually there are part two type of biasings generally. So that is called forward biasing, other is called reverse biasing. So the diode is forward biased by applying a positive voltage to the part anode relative to that of the cathode, and this reduces the part barrier potential and allows the current to flow through the diode. That means when you can apply the part positive voltage to that p type and negative voltage to n type, so the width of the width of this dripping layer will simply decreases, and when the width of the depression layer decreases, that you can find there is there is the barrier potential who develops. This allows the part current to flow through the part this junction actually. Similarly, in case of the reverse bias, so when the reverse bias voltage applied, that reverse bias voltage applied a positive voltage to the part cathode. You can see, just you can see the part, if you can change the part actually, is I can change the part terminal. That means I can change the polarity. That means n plus will be connected to the positive and p plus will connect to the part negative here. Then you can find this width of the depletion layer or this middle layer will be simple increases, and this simple blocks the current not to move to in the circuit actually. Okay, so this increases the barrier potential and block the current to flow. So this is the part that the concept happens in the part in the biasing actually. Okay. Now the frequency response, if we can come, so we can draw the part the frequency response curves of the part diode, or you can study the frequency response. So the power diodes are generally not used in high frequency applications because there are significant charge storage and the recovery times. So as there is a significant charge storage takes place in the during the part biasing, and there is a high recovery time, so that is why the paradigms are generally not used in high frequency applications. However, they are optimized for low frequency applications such, such as reverse recovery time and also the junction capacitance. So these are the these are the part some field or the some areas where you can find the frequency response curve of the power that can be part implemented. So you can see the reverse recovery time part, the time it takes for the diode to switch from the conducting to blocking state actually. But power diodes have a longer time, okay, that compared that of the part signal diodes, limiting their use in the part high speed switching actually. Okay, and the junction capacitance, this is the part one component of the part circuit. So where you can find this is the capacitance of the depletion region, because once the biasing is created, so there is a contact potential developed at the junction, and that may be create a part a junction capacitance at the depletion region. So pioneers have the higher capacitance and which further limit their frequency response. Okay, so this is the part this is the frequency response characteristic that you can obtain in a power diode actually. Okay, similarly, you can go to the part VI characteristic of this part power diode. This is the part VI characteristic of a power diode. It is just like a part simple junction diode. So we have taken the part forward bias voltage in this x-axis, and also the part this current in the y-axis. Similar the reverse voltage, reverse current in this direction, and the reverse voltage in this direction. So, as you know, when the voltage is applied at the part in the forward bias diode, so there is actually generation of the part, the charge pair takes place, and this charge pair, when it voltage is zero, so you can find there is no emission of the electron takes place and the current is zero. But at a particular voltage, when that voltage rises immediately, there is sudden breakdown of the part. This semiconductor takes place, or the breaking of the part, the bond, covalent bond takes place, and the current rises for suddenly, for which you can find there is a part sharp increase in current, and the voltage at which the current rises sharply or suddenly, then that is known as a part knee voltage. And for a positive voltage, we are giving plus 1 volt, and similarly, the voltage at which the current drops suddenly, that is called the part reverse bias voltage, and there is a drop of the current takes place in the part also the reverse direction. So this is the same things that I have written here. You may part read out there. Okay, am I clear? So am I audible to all? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Are you follow my points? What I'm telling? Hello.
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Okay. So if you're in doubt, you can please ask me. Okay. There is no, you can ask, okay, without any part hesitation, you can ask me. Okay.
Okay, sir.
See, then you can see actually for some of the applications. I just put the part some of the applications. I list the part some of the applications. This diodes actually provides uncontrolled power rectification. That means it acts as a rectifier. It is used in different applications like DC power supply for charging the battery, inverter, and AC rectifiers also. Okay, and these are used like a snubber network and the freewheeling diodes. So these are the part some complex network where the power diodes can be part used due to their characteristic like voltage and also the part high current. Okay, and these diodes are also used as a feedback circuit and freewheeling diode and also the part high voltage rectifier. Okay, and in the reverse condition, breakdown condition, when the current and the voltage of these diodes are part huge, no, the power dissipation can be high, so the device can be part simple destroyed. So depending upon the part voltage and the part current, whether that power diode can be used or not, that can be part decided here. Okay. So this is all about a part simple a power diode. Now let me come to the part light emitting diode. So I think that these things you may have read in a part base level or in part also, but still I put it part actually some ideas in the part LED, and you all of you know the light emitting diode, okay, is also part PN junction diode, and it is a specially doped diode. You can see specially doped means the impurity just in the previous power diode I put the part P plus and part N minus. Okay, similarly this is also part a heavily doped or specially doped diode and made up of a special type of part semiconductor. Okay, and when the light emits in the forward bias, so it is called a part light emitting diode actually. Okay, and this is the part the LED available in the market, and this is the part symbol. So from the previous power diode, it is just a part different part. So we are putting the part the two arrows here as it emit the part type. That is why we call the part LED. Okay. Similarly, the construction of part LED you can find the construction of LED is very simple, as like that of also part this power diode, because it is designed through a part deposition of a three semiconductor material layer over the part a substrate. That means we can deposit the part simple this part this semiconductor material over a part substrate, so that we have the part that three semiconductor layer where you can find the different type of charge carriers are part available, and these three layers are part arranged one by one, where the top region is a p-type region, the middle is a part simple active, and finally the bottom region is a part n-type. That means between p and n-type there is a part sandwiching structure is here, and that sandwiching structure actually helps in the creation of the part the hole and the part electron pair, and the three regions of semiconductor material can be observed in the construction. You can see here. So this is the part of you can see this is a part P type, this is a part N type, and we just developed all this P type and N type material over a part substrate here. And this substrate is a part simple a reflecting coating cathode, and here you can find a part also part aluminum part coating is given to just have a part metallic contact, or this is a part electric contact is given, and another is a part insulating layer is given, that is part SiO2 silicon oxide layer. Okay, and this LED actually made up a part may always operate in a part forward bias condition. Okay, just the same things are written in the construction. The p-type region includes the hole, and the n-type region includes the part electrons. Okay, where the active regions includes both holes and the part electrons. And when voltage is not applied to the LED, there is no flow of the electron and also the hole. So this is a part simple stable condition. Once the voltage applied, then the LED will forward biased. So the electrons in the N region, so the electron from the N region and the holes from the P region will part move to the active region. Okay, active region means where there is an exchange of the part the charge carrier takes place, and there is a part that when there is a combination of the part charge carrier takes place, this will be emitted as the part heat and the light. But the heat of the heat generated, that is simple get within the part dispersed inside the material, and the light is simple coming out, and what you call the light emitting diode, because the charge carriers like holes include a positive charge, whereas the electrons have a negative charge. So the light can be generated through the recombination of the part polarity of the charges, and during that combination you can find there is large amount of heat and the light is per simple produced. But that amount of heat simple get dispersed within the material or the devices, only the light is per simple emitted here. Okay, is it clear to all of you?
Yes, sir.
Okay,
Yes, sir.
similarly let me come to the part this working of the light that LED here. I told the part this construction the construction and also see. So if you can look the part diagram actually you can see. So this is a part simple part a P type layer. Okay, and also part N type layer. You know this is the part three holes, that is the P type layer, and this is the part the electron layers. Okay, so when we just apply the part voltage actually there is a part there is moment of the charge carrier takes place from both the P type from P region to also the part N region, and you can see another part region actually there. This is the part free electron, and this is the free hole, and this is the part electron energy that you can say, and this is the part valency band, and this is the part simple conduction band here. So the light emitting diode simple we know as a that is a part simple diode, where the diode is photoburst. the electron and the holes are moving fast across the per junction, and they combine constantly, removing one another out actually. That means when we can apply the part voltage at the part this two terminal, there is a recombination of the part electron hole pair takes place, and each of the part the each of the removal of the hole that filled by a part electron, and each electron removal of the electron is also create a part hole. So due to that electron and the part the whole part movement from the both the p and part n, there is constantly recombination takes place, and it emit the part light actually. Soon after the electron moving from n type to the p type silicon, it combines the whole, and then the part simple disappears, and that disappears is nothing but appears a part light that you can find. So when there is recombination of the part this free electron and that of the part the whole from the part this valence bond takes place, this can produce a separate light actually. Okay, hence it makes a complete atom and more stable, and it gives little burst of the part energy in the form of tiny packet or the photon of light actually. Okay, when this p-n junction diodes is forward biased, the barrier with its part simple reduced. I told that so when there is a recombination in the forward bias condition, what you can find, there is the width of the potential barrier decreases, and more charge carrier to be passed through the per junction, giving a part high current, and accordingly we can get the part. You can see in the part this forward bias characteristic of the power diode. That's how the part current increases suddenly at a particular voltage. The similar things also happens in case of the part LED here. So when the PN junction diode is forward biased, the barrier width is reduced, raising the potential energy on the N side, and lowering that of the part P side actually. And the free electron and holes have sufficient energy to move into the junction region. Okay, and if a free electron meet a hole, it recombines with each other, resulting in the release of the part light photon actually. So in this part diagram you can see, so when the photobias actually applied, the recombination of the electron and the hole takes place. Okay, and this free electron hole have the part sufficient energy to move into the junction region. So this is the part junction region, and that is, you can see this is a part conduction band and it's a valence band. And here, so you can find here there is a formulable, and in that formulable you can find that the maximum charge carriers to be occurs, and that is recombination of the electron hole takes place, producing the part light or the a photon of part energy h. Okay, now yes, so you can see actually the real things happens inside the part LED. Just you can see this is a part N type, this is a P type. Okay, this is a part cell we applied here. This is plus. You can see this is polarizing. So P type counterpart positive and N type counterpart negative. So when this voltage applied across the part this semiconductor here, you can see there is a part this whole that electron is moved from this region, and the vacancy which is created, that is created by the part that is get filled by part, or when the electron moves to this region, then it create a part hole. So like that part it happens, there is a recombination takes place inside the part this junction, and you can find the part light is part emitting. And this is the part you can see, this is a part LED 07. Okay, so this is the practical the practical LED what you can find in the market, and this is the part simple the internal design. So this is the part the part way how the part LED works and produces a light, that is what mentioned here. Okay, hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, just the same light image diode, I'm just using a part circuit and how it is get biased that I have mentioned here. You can see the most of the part LEDs have the voltage rating from 1 volt to that of 3 volt maximum. So that is why you are using the part this LEDs that to be part design most of the part circuit and also the for the decoration purposes. Okay, so because they can part only that varies from 1 volt to 3 volt, and they can the current rating from the 200 milliampere that of the 100 milliampere. So that is why now the part the LEDs are part the most of the part circuits are the or most of the part decoration done with the part this LED lights. Okay, and you can see that if the voltage actually here the 1 to 3 volt applied to LED, then it functions properly due to the flow of the current or the applied voltage, and will be the operating range actually. You can see this is a circuit diagram. So where the LED is always part connected in the part in a forward biasing condition here. So when you can just part connect the part this power supply here, the current will start to flow through this part resistor. Okay, and then from the part P to the part N type, and the current flow takes place actually but in this part in clockwise direction here. Okay, so similarly, if the voltage applied to the LED is in higher than that of the operating voltage, so what voltage we can apply here? VD, that is the voltage applied to the diode, is higher than that of the part your operating voltage, then the depletion region within the light emitting diode will break down. Because if you can apply the part actually a higher voltage across, which is more than that of the part LED voltage, then there is you can find there is breakdown takes place in the part the depletion region and within the light within the part LED, and that will be breakdown due to the part high flow of the current. So this unexpected high flow current will damage the part device. So that is why we can put a part resistor so that it can control the part current through the part resistor, and a regulated supply of the voltage can flow through the part this LED to give a part continuous emission of the part light actually. So this can be avoided by connecting a resistor, what I told already here, okay, series with the voltage source and that of the LED. And the safe voltage rating LED will be ranged from 1 volt to 3 volt, whereas safe current ratings range from the part 200 milliampere that of the part 100 milliampere. Okay, so this is the part the circuit diagram which describes how the LED can regulated with a applied voltage across the part LED voltage also. Here the resistor which is arranged in between the voltage source and the part LED is known as the part a current limiting resistor, because this resistor restrict the flow of the part current, otherwise LED may destroy it. So this resistor plays a key role or a crucial role in protecting part LED actually. Otherwise, if you can directly connect to that of a part supply to that of the part LED, then you can find there is the damage to this part LED takes place. So that is why, so whenever in any circuit you can find or any circuit you can open, you must find the voltage are not directly on the part LED, rather that you can put a part simple a resistor here actually. Okay, is it clear to all? Hello.
Yes, sir.
Okay. Okay. Then, so coming to the part IV characteristic of the part LED. As I told the part, this part as you know the part LED has also part that can produce the part different color of the part light depending upon the part material used. See, these are the different type of part light emitting diodes and are available in the part market, and therefore the different LED characteristic which include the color light or wavelength radiation or the part light intensity. So if you can take any of the part material, so this is for a part a single diode which may be operated for infrared range, this is for red, this is for the orange, and this is for the part blue color. So in most of the cases you can find the diode characteristic report like that. So depending upon the material or the part wavelength of the light used or the part the power supply, we can find the part different color of the part light here. So the important characteristic of the LED part, that is color actually. In the starting in the starting use of LED, there is a part only red color was here. As the use of LED is part increased with the help of the part semiconductor processes and doing the part works on the part new material of LED, the different colors are formed. But I have to part mention to here that when you can plot the part plot the graph between the voltage and the part current for LED, we can find the part nature of the core is just like a part in a straight line after a part after a sudden jerk or after sudden rise actually. And this all this voltage where at which the part voltage the current rises suddenly, these are known as the part simple the knee voltage. So depending upon the part color of the light or the material, that you can find the different knee voltages, and hence they have the different color of the part light that you can find actually. Okay, so similarly the frequency response of the LED, you can see the this frequency response actually we have the part the different part modulation speed actually. Okay, so modulation speed means it is includes of the rise time, fall time. Okay, and that between the rise time and fall time we have the part bandwidth, and also the part we have to read the part capacitance and the part parasitics. Okay, so so in this frequency response of the part LED, you can see one is called the part modulation speed actually. It is the per time that taken by the part LED to increase from 10% to 90% of the part its maximum intensity when it's part switched on. That means when you can apply the part voltage. So during that time, it takes about 10 to 90% of its maximum intensity from the part supply actually, so that it to get switch on. Okay, and fall time is what? It is the time taken by the LED to decrease the part its intensity from 90 to part 10% of its maximum intensity when switched off actually. Okay, so this is a rise and support fall time. And the typical values for the part general purpose LEDC are the part microsecond range, while high speed LEDs are part can have rise or fall time in the nanosecond range actually. Okay. Hello. ନାଇଁ ମାନେ କାଲି ସବୁ କହିଛନ୍ତି ବସିବା ପାଇଁ। Hello. Yes.
Yes, sir.
Okay. So this is the part rise time and fall time. Then we have the part bandwidth. The modulation bandwidth of LED is part inversely proportional that of the part its rise at the fall times. And high speed LEDs at part have can have bandwidth up to part several hundred megahertz, making them suitable for the optical communication system. Because depending upon the different bandwidth of the part the devices, okay, we have the part different applications. So and that idea you can get from the frequency response of the part LEDs actually. And then you can go for the part capacitance. Okay, so the junction capacitance and the parasitic inductances can limit the part speed at which an LED can per simple modulated. That is why this capacitance actually for developed while there is a recombination of the part hole and the part electron plate expressed at the part junction. Okay, and the high speed LEDs are for particular designed to minimize this effect actually. Okay, and then we are using the for different material, so for which you got the for different color of the light. Okay, it is just like you can see the part this metal is to part LED effect because this metal wire is because to regulate the part speed of the part or the operation of the part LED, we have to part is can the different color of the different material. And for example, if you can use a gallium arsenide, LEDs are typically have faster response because this is a part simple compound semiconductor, and where you can find the charge carriers or the free electrons are part more available, and that is the part addition of the part the pentavalent and also the part trivalent impurity that makes the part this devices very fast. Okay, then that of the part gallium nitride LEDs. Okay, now you can see the part is application of LED. Because of their part miniature size, they are part widely used in part numeric and part alphanumeric display devices. You can see this is part this is a very general applications of the LED in the part many of the part devices and also the part the household applications, and they are used as the part indicator lamps, and they are used as a light source in fiber optic communication system. Infrared LEDs are particularly used in burglar alarm, and they are used in the part image sensing circuit used for the part picture phone, and also they are used as a part pilot light. Okay, in the part in different applications of the part aeroplane also. That infrared LEDs are part widely used with the photo diodes or photo transistors to enable short range wireless communications. Okay, so these are the part the different applications, and you can see. So for example, if you want to write a part simple part on a digit 8, you can see there is a part the different part LEDs are part there, and if you want to write the part 4, you can accordingly there is a part is switching conditions are there, and you can add the 4, you can add the 2, you can add the 3, you can add the 4, anything any numeric that you can add using the part 7 segment display actually. Okay, and this can be done with the help of the part LEDs actually. Okay, now coming to part this ledger diode actually, and this the what so ledger is simple stands for the light amplification by stimulate emission of the power radiations, and it is a part simple semiconductor based PN junction. So this ledger diode is nothing but a part a semiconductor based PN junction device, and that converts the part electrical energy into the light energy similar to that of the part LED. But one thing that you can find in this ledger diode is different from that of the part this LED part. So there is some basic mechanism that takes place in the laser diode, which is not happens in case of a part in a LED actually. So that is why These laser diets are part more efficient and also the part more acceptable in many cases as compared to that of the that general LEDs. Okay, it generates a part high intensity coherent and monochromatic light, and you can see this the part the diagrams, or you can see this the part a general structure of a part laser diode. Okay, and the basic principle is part you can see this also symbol here. You can for this laser diode. Okay, and when the p-n junction diode is part forward biased means just I'm telling the part operation. So all the diodes are all the part LEDs are operating part forward biased condition, but in the same way here the laser diode can also operate a part in the forward biased condition. Like when the p-n junction diode is forward biased, the electron from the n region and hole from the p region cross the junction and recombine with the part each other. And during the part recombination process, the light radiation is released from a direct band gap semiconductor like gallium arsenide, and this light radiation is simple known as a part recombination radiations. Okay. Hello,
Yes, sir.
Yes, sir.
are you getting
Yes,
me?
sir.
Yes.
Yes. Yes, sir.
Okay. So uh, then you can come to part construction. You can see the part, this is the part basic design or the part schematic construction of a part, this laser diode. So here we have the part the p type and part n type part semiconductor. Then this junction is called the part the pn junction here, and there the part the two metallic part the terminals are there where you can apply the voltage. And when you can apply the part voltage to this actually, or the it is for bias because this is p type is positive and n type for negative. So there is part actually there is recombination of the part this electron hole takes place at this junction. And since at this junction so there is a part some excitation process takes place, creating the population inversion. And in that population inversion there is a spontaneous emission and stimulated emission takes place, and that stimulated emission will produce a part a radiative transition, and which is nothing but a part laser output. Okay, so the above figure or this figure simple shows a part a simplified construction of a laser diode which is similar to that of the part light emitting diode actually, and it uses a part gallium arsenide topped with elements such as selenium, aluminum, or silicon to produce the part P type and N type semiconducting materials. Okay, and while a laser diode has an additionally active layer of undocked intrinsic gallium arsenide have the thickness only a few nanometer, and that is sandwiched between the part this P type and the part N type layer, and it is a part thin layer that the laser is for the laser light is for produced. So you can see this is a very thin layer of the part some nanometer or nanometer thickness or some part micrometer thickness, and from that thickness you can find the lights are part emitted here actually. And within that thickness you can find the all the recombination of the part electron hole takes place, and it is basically produces upon this excitation process like three different processes like called the stimulator absorption, spontaneous emission, and also the part stimulator emission. And since this is basically follows the part the laser activity or laser process, we call it part laser diode here. Okay, now how to work actually the same way also for I just for actually for explain the power diode also the same way you can find this laser diode also for work. That is simple the recombination of the part three electron of holes are takes place inside the part this junction region, and they can produce the part light the same that for as like a part power diode here. Okay, then you can see the super band gap what I to actually is the super band gap here. And from that band gap you know that support there is a difference in part conventional band, and that conventional band and the valence band difference will produces the part emit of ready the photon having energy for h nu, and that is sc by lambda. And from that also we can calculate what different type of the color of the light that is coming out, and that can be determined by lambda is called part sc by part eg actually. Small problem that you may be face. Okay, now, when we go to the part actually the biasing of this laser actually, a laser diode. So the laser diodes are typically operated under the forward bias condition. The biasing involves applying a voltage across the pin junction to inject the part carrier into the active region. That means when you can connect the part this or biasing the part this laser diode, that is p type with positive and n type part negative, or the polarity will change, then accordingly you can find actually this the light would be part emitted, So in some cases you can find actually the particular desired wavelength. In some cases you can find very small wavelength. So which is also can be generate a small light signal from the material actually. Okay. Then you can find there is a part, there are some definitions you can find the threshold current, because this is the part certain, or this is the part minimum current, or known as threshold current must be exceed to the part achieve latching action. And above threshold operation you can find this increases the part current, further increases the part output power of the part laser actually. So these are the part the two, threshold current and also the part threshold operations, that the two terms that associate the part the laser diode operations here. Okay, because above the threshold current you can find that there is a part recombination takes place, and you can produce a separate high value of the part intense of light. But below that you can find there is a less emission of the part light, or the part light intense part simple decreases. Okay, and that is called the part, and that operation condition is known as the part simple threshold operating condition. And you can see also the laser diode the same as that of the part this LED. Okay, in that cases you can get the part the knee voltage actually very close to that of the part this zero, or the part or the low of low knee voltage. But in this case you can find a part high knee voltage, and the current also suddenly rises to give at a particular voltage to produce a part high current here, and also the part high intensity of light. Okay, so this is the VI characteristic curve. So the resistance, the voltage, and the part laser diode current. Okay, and a laser diode is essentially a PN junction diode. I have already told, having a junction voltage drop called the forward voltage, but it is larger than that of the part a conventional diode actually. So most laser diode has a voltage of about 1.5 volt, for 1.5 forward voltage you can see here, and the laser diode does not conduct the current until the voltage reaches the part forward voltage. You see, so laser diode not operate on the not the part actually operating condition when we are not getting actually this forward bias voltage, and then the current simply exponentially increases, and the temperature affects apart negatively the forward voltage of the part laser diode here. Okay, so this is the part VI characteristic of a part simple the laser diode here. Now coming to part frequency response, you know, the frequency response of this laser diode simple indicate but how its output power varies with the part modulation frequency of the part input current actually. Okay, and this from this actually we can calculate the part modulation bandwidth, and relaxation oscillations, and also the part high frequency performance. So what is that part modulation bandwidth actually? And the laser diodes have a finite modulation bandwidth beyond which the output power cannot follow the input signal effectively. So that is why we have a part a limiting value of the part this output voltage, and what we call actually modulation bandwidth here. Similarly, the relaxation oscillations, these are the oscillations in the output power caused by the interplay between the carrier density and also the photon density in the part cavity. So that means when there is a recombination of the part this electron hole takes place, then we must has to be we must has to be supplied the voltage in such a way that there is a controlled recombination takes place. Otherwise, if there is no control in that recombination, that may be create a part a high power loss. Okay, and that is why we have putting a part some relaxation oscillation, so that one after one, so there is recombination takes place one by one, not actually part simultaneously. Okay, so then the high frequency performance is part, the frequency response is affected by the factors such as carrier lifetime, and the parasitic capacitance, and the quality of the part optical cavity here. Okay, because since we have a part laser diode, we must have a part resonator, and the resonator is simply designed with the part the mirrors, and that mirror actually allows the part the back and forth motion of the reflected photons to align themselves in a particular direction, producing a part high output voltage. So this is the part high frequency performance that can be attained through the part laser diode. So that is why laser diode is a part more efficient as compared to that of the part power diode, and also the part LEDs actually. Okay, now these are the parts some characteristic actually in a solid semiconductor like the active medium by pumping method. You can read power output, nature of the output, wavelength of the output that is coming out from this laser diode. Okay, and similarly there are parts some of the part advantages, and these lasers are very small in part size and compact. It is very high efficiency. The laser output can be easily increased by increasing the junction current. It is operated with a part less power than that of the ruby laser and also the part carbon dioxide laser. The carbon dioxide laser is a part simple a gas laser and this is a part simple solid laser. Okay, and it requires a part very little additional equipment. Means as I told, it's a very